In today's discussion, topic under discussion is chloroquine, which is one of the anti-malarials. Okay, so what we are going to discuss with you guys in this lecture, first of all, I'll tell you people about the points that are actually the part of our discussion. We'll talk about the anti-malarials term, then its class, that is 4-aminoquinolone. Then we'll talk about the chloroquine in detail, like we'll talk about the structure, the IUPAC, the mechanism of action, the SAR, the therapeutic use, the synthesis. And this structure will be discussed in a very different way. It will not be just like that, which is written in the book. It is actually from the book, taken from the book. But here I would tell you people about the trick to learn this structure in a very easy way. And yes, our entire lecture is easy, and as usual, you guys are commenting and providing your compliments in the comment box. We observe all, so you guys are enjoying, and we are getting motivation for you guys that we make much more lectures for you guys. Okay, getting to the point, that is the chloroquine, anti-malarials. We know that we have several drugs in the anti-malaria, means those drugs which are actually used to treat malaria. From all those drugs, we have a class that is 4-aminoquinolones. From this, we are going to discuss chloroquine. And I hope you know the meaning of this 4-aminoquinolone. Simple. If we have the quinine structure, and in that, if on the fourth position, one, two, three, fourth, on the fourth position, if there is a amino group attached, then that is actually named as 4-aminoquinolone. Okay, so in short, chloroquine is from the 4-aminoquinolone. Means if we are discussing, if you're going through the structure, in its structure we will find this kind of ring, and there will be the attachment of the amino. The very important point that you guys must remember, the 4-aminoquinolones have this kind of structure. So this is the quinolone structure having the ammonia on fourth position, amino group on the fourth position, not ammonia, sorry. So amino group is, if on the fourth position is available, then that is actually called as 4-aminoquinolone. So now this is actually the 4-aminoquinolone. This is 4-aminoquinolone. So from the 4-aminoquinolones, we will discuss the chloroquine. So what we got now? Simple. Half of the structure is actually, one can say, discussed and have been cleared in this particular point, that is 4-aminoquinolone. Now we're going to discuss the chloroquine in detail, the structure of the chloroquine. Here is the structure of the chloroquine with us. A moment earlier, we talked that chloroquine is actually the 4-aminoquinolone, mean that it is actually one of the 4-aminoquinolones. So it must be having this structure, and here it is. Ring structures having the nitrogen amino group here. Okay, now this is actually the amino group available. So because of this, now we can say, we can proudly say that this is actually the 4-aminoquinolone. The remaining structure is actually the part of this structure that you guys must remember. Now to remember the entire structure in an easy way, I will tell you people about the trick name. Through this trick name, you guys will become comfortable to write the structure anywhere, wherever you are asked in exams. So now what is the trick name? The trick name is quinolone 4-amino plus diethyl amino pentane. Means just have 5 carbons, 1, 2, 3, 4, 5 pentane, and with that just add diethyl amino pentane. Okay, 5 carbons. Now what you are going to do is simple. By means of this, taking the help from this and this name chloroquine name. So we are taking the help from 1, 2, 3, 4 points. From these 4 points, we will draw the structure of the chloroquine in a very easy way. So in short, you are asked in exams, the question is draw the structure of the chloroquine. Now you became blank for a while, and after that you remembered my trick. The trick is, a boy and a girl, go through these points while you are writing the name of chloroquine in a perfect way. Now what are the points? First of all, look at the name, then come to the quinolone, number 2, 3 and 4. These 4 points must be kept in mind. You must memorize these points. So if you go through these points, then it will become very easy for you to draw the structure of the chloroquine. How? Like, very simple and easy. Let me take tissue to erase a bit the portion here to have space. Okay, so what I told, the trick is to go through these points if you want to draw the structure of the chloroquine. Chloroquine, first look at the name, chloroquine. What are you getting from the name? Simple. You're getting from the name two things. One is chloro. Here is the name, chloroquine. Chloro stands for Cl, queen stands for quinoline ring. And what is the quinoline ring? Here, this is the quinoline ring. So just draw this. First of all, draw the quinoline ring. One. This is the quinoline ring. This is the quinoline ring. So just drawn. Now, with the quinoline ring, there is a chloro group, and right here, chloro. After that, what we are having is the remaining points. 1, 2. From the name, we got this structure, and quinolone is available here. Then go for the 4 amino. On the fourth position, 1, 2, 3, 4. On the fourth position, there must be amino. And as we have another remaining, so forget about the H available here. Suppose we have amino like this. Just erase this H because we have another thing remaining, that is diethylaminopentane. Now just take this diethylaminopentane and just paste it here. You will get the entire structure of the chloroquine. How? Like, very simple. Carbon, 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 1, 2, 3, 4, and 5 carbon chain, pentane. With that we have nitrogen, and with that we have C2H5. So like this, what we got. Now just go for the valencies and just fulfill the valency, and you will get the structure. Chloroquine, the structure of the chloroquine being drawn. This much easy is this chloroquine drawing. So how we just got through this? Very simple. Question was asked to draw the structure of the chloroquine. We took the help from the trick of Dr. UUT lectures. That is, look at the name, chloroquine, then go for the quinolone, 4-amino diethylaminopentane, memorize these, then just jot that on the paper and you will get the structure of the quinolone. Simple. Chloroquine, we split the word chloroquine into chloro and quine. Chloro and quinoline group. Chloro attached to the quinoline group. And here is your quinoline group. Along with that we have chloro attached. Then we move towards the quinolone. So this is our quinolone available. Then on the quinolone we have 4-amino. That is 4-amino. In the fourth position we got amino here. Then I told you just erase hydrogen here available with amino. Instead of that, on place of that, replace that hydrogen with this branch structure. That is actually diethylaminopentane. Now this entire structure is available here, and like this, the structure of the chloroquine is being drawn. I hope you got the entire structure. Now let's come towards the mechanism of action. IUPAC and mechanism of action. First of all, mechanism of action. Simple. According to the studies, when the parasite enters into the body, that will actually split the hemoglobin into heme and globin. The heme will be utilized by the plasmodium enzymes to convert the heme into hemozoin. Then that hemozoin is responsible to cause fever, anemia, and splenomegaly. What we do now, we take chloroquine, or we indicate chloroquine. That chloroquine is responsible to inhibit the synthesis of hemozoin. It is actually bind to the heme, and then the heme will be actually available in the body. So hemozoin won't be synthesized. So if the hemozoin is not synthesized, then the symptoms that we see like fever, anemia, and splenomegaly are actually lost. So what is happening then if the heme is available and hemozoin is not synthesized? This heme, which is available in the blood, that heme will move and will start breaking, or you can say start killing the plasmodium, the parasite available. The malarial parasite will be killed by this heme then. So in short, heme is actually beneficial for us and hemozoin is harmful for us, and the vice versa is for the anopheles, like for the plasmodium parasite. Anopheles is responsible to go through the entire pathway of malaria. Well, simply coming to the point, making it simple and short, when we indicate chloroquine, that will inhibit the heme. When the heme is inhibited, when the heme is actually made free, and inhibition is done of the formation of the hemozoin, this chloroquine will inhibit the hemozoin formation. Hemozoin will not be synthesized. If the hemozoin is not synthesized, then fever, anemia, and splenomegaly, etc. like symptoms will not be seen. So like this, what will be happening inside the body? Simple. This heme will be free to attack the malarial parasite, plasmodium. So then plasmodium will be killed, actually, in short, like that. Okay, I hope you got the entire mechanism of action. Well, now let's come towards the IUPAC SCR therapeutic use and synthesis. Up till now, I hope you got the entire lecture. And one more and interesting thing you guys must remember is that +92 340 80 60081. So the remaining part, contact us here. How you got. Thank you for watching.